Okay, just like last time, you can bring that formula sheet, print a clean formula sheet off from Canvas, and you can write anything on the back that you want to. Okay, if it were me, I would write down the 6 question types and where to go on my calculator and what to type in. Because this test, either you kind of know what to do and it's all great, or you just stare at it and have no idea. So there's not a, for some reason, partial credit just doesn't work out very well on this one. Okay, so you've got to know what the question is and then where to go on the calculator to get the answer to that type of question and how to type it in the calculator. So like I said, you can put a prayer to Jesus on the back. I don't care, but that's what I would put on the back. So there won't be vocabulary on this test. It's just straight, here's your word problem, work the word problem. Okay. So just like last time, you know, come with your calculator, make sure batteries are good, something to write with pencil wise. Make sure you bring your picture ID, and then you bring your formula sheet with anything written on the back that you want to. Okay. All right, just like last time, I'm going to do the outline. It'll take probably, I don't know, an hour or 45 minutes. We'll see. Then if anybody has a question, you're welcome to stay on afterwards. Also, if doing an individual Zoom works better for you, please feel free. I'm happy to do that. Okay, just send me an email and go, can we Zoom? And we can do it pretty much any night this weekend. Just, you know, you don't want to be doing it Tuesday during the day. It's too late. Okay. All right, so before I kind of start the outline, does anybody have an initial question that you want to get answered before we kind of start? Are we good? Okay, just like last time, I'm going to kind of share the screen and kind of write on this whiteboard. Okay, these are kind of the 6 questions. Now, what it's covering is going to cover chapters, not everything in every one of these chapters, but it covers chapters 6, 7, 8, and 10. All right, so 6, 7, 8, and 10 is kind of what we're talking about. Now, these are kind of the questions it's going to say. So when you're reading the word problem, you need to look for these. One question is going to say construct, and that's the way I'm going to phrase it, a confidence interval estimate. So it's telling you to construct a confidence interval. All right. Now, another kind of problem that it may ask you to do, it may ask you basically to find a sample size. Now, sometimes it literally says find a sample size, but a lot of times somewhere in the problem instead, it will say how many. Like, how many people must you survey? How many items must be in your sample? Okay. So if it says construct a now here's where people get confused. It'll say something like, how many people must you survey to be 99% confident that the, so just because it says confident, that doesn't mean it's a confidence interval problem. If it's a write a confidence interval, I'm going to say construct a confidence interval. Okay. So you can't like glance at the problem. You've got to read the whole thing. If it's a sample size, it's either going to say find a sample size, or it's going to say how many. How many people must you survey? How many things must be in your sample? Okay. Another kind is going to ask you to find a probability. Now, on your midterm, you had to find a probability, and there's no way to get these probabilities confused with the other probabilities. So if it asks you, what is the probability that in a class of 30, at least 3 are right-handed? You know, what's the probability that IQ scores are normally distributed with a mean of 100 and a standard deviation of 15? What's the probability somebody's got an IQ above 123? Okay, so there's no way to get the probabilities confused, but it's going to tell you what is the probability or find the probability. Okay. The other thing it might ask you to do is it might ask you to find a value. All right. Let's make that like what IQ score separates the top 10% from the rest? Well, it didn't ask me, it didn't say construct a confidence interval. It didn't say how many people must you survey. It didn't say find a probability. So kind of by process of elimination, it must be find a value. Okay. The other two are like this. The other two are about hypothesis testing. And it always says something like test the claim that. So when it tells you to test the claim, see, that's not didn't tell you to construct a confidence interval. It didn't tell you how many people must you survey. It didn't tell you what's the probability. It says test the claim. Okay. And then the last one is about linear correlation. And that's kind of the chapter 10, which you may not have gotten to yet. Okay. But again, it's going to phrase it like this. Something like, let me look in the book and see how they word it real quick. It's going to ask you if something is significantly linearly correlated. Okay. Yeah. So it's going to ask you something like, is there a significant linear correlation between, and it's going to give you a couple of things to check. Okay, so if you read the problem, as soon as you read the word problem, you decide which of these 5 questions it's asking. Because that's going to tell you where to go on your calculator and what to type in. Okay. Is it asking for a probability? Is it asking me to find a value? Is it asking me to make a confidence interval? Is it asking me to find a sample size? Is it asking me to test a claim? Or is it asking me about linear correlation? So helps if I put 6 instead of 2 5s. So there's only 6 question types on the whole test. So when you read the word problem, that's the first thing I want you to decide. Which of those 6 questions is it asking me? And then you go to that one type of question and what to do on the calculator that you have kind of written on your back of your sheet that you've studied. Okay. Now, all right. So let me get that erased, and then I'm going to go chapter by chapter. Okay. All right. So the first thing I'm going to start with is chapter 6. Now, the first thing on chapter 6, it might tell you to find a probability. Now, first of all, I need you to remember that probability is always a number between 0 and 1. If you cannot get an answer bigger than 1, it's not right. You cannot get a negative number, it's not right. Okay? Because 0 means impossible. So 0 is never and 1 is always. And everything in life is somewhere between never and always. All right? So sometimes somebody's not reading the calculator and it'll have like 2.13 and they just stop and write down and they don't keep reading and it says E -8. Okay, so the calculator is not going to give you a probability bigger than 1. All right, it won't. So if there's a p-value bigger than 1, that means you need to read all the way out to see where to move the decimal. Now, there are two, when the problem on the exam says to find a probability, the first thing I need you to do is I need you to draw a picture. And by a picture, I mean the normal curve. Now, remember what the normal curve looks like. You know, that's the one that's got the hump in the middle and then it's symmetric on either side. All right. And then I need you to shade the area you're looking for. Now, if it says more than, you're going to shade to the right. If it says less than, you're going to shade to the left. If it says between, you're going to shade between. That one's not a problem. But you got, sometimes it'll say, what's the probability that a person has an IQ score of at least 100? At least does not mean less than. At least means that's the minimum. So you would shade to the right. So again, you can't skim, you've got to read. So less than, at most, below, those are all words that tell you to shade to the left. Above, at least, more than, those are words that tell you to shade to the right. Okay? Now, there are two kinds of probability problems. One is a regular normal curve problem. And the second type is what we call central limit. Now, how do you know whether it's a regular normal curve problem or central limit? On a regular normal curve problem, they are only picking one. What's the probability that a person, see, that's one person. What's the probability and IQ score? That's only one score, okay? The way you know it's central limit is if they're picking more than one. And I'm calling that a group, okay? Anything more than one is a group, whether they're picking 2 or 200. Now, these problems are worked the same way. You draw the picture and you shade the area you're looking for on both of these. The only difference is central limit's got one extra step. On central limit, you've got to change the standard deviation. And the way you do that, I'm just going to put S for standard deviation. Your new standard deviation is your old standard deviation divided by the square root of N. And N is your group size. So if you're picking 2 people, you've got the square root of 2 down here. If you're picking 200 people, you've got the square root of 200 down there. So normal curve and central limit are worked the same way. It's just central limit has one extra step. And the one extra step is you change the standard deviation. You don't change the mean. You only change the standard deviation. Then the calculator is going to do all the work for you. All right. You're going to use the calculator now. So I've drawn the picture. I've shaded the area, and now I'm going to use the calculator. And you're going to go to second. You're going to hit your second key, and then you're going to hit your vars key. All right. That gets you to the distribution. And you're going to pick normal CDF. Now, there is a normal PDF. You never pick it. You only pick normal CDF. And it's going to want you to tell it 4 things. The left endpoint of the shading, comma, the right endpoint of the shading, 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 the right endpo comma, the mean, and the standard deviation. Now, sometimes some calculators, some versions will say lower bound and upper bound. Lower bound is your left endpoint, upper bound is your right endpoint. Now, sometimes you have to fool the calculator. Now, what do I mean by that? Sometimes you don't. Like, it would tell you something like the mean of IQ scores is 100, the standard deviation is 15. So remember, in the dead center of a normal curve, you put the mean. So if it said, what's the probability somebody's got an IQ between 90 and 120? Well, then your left endpoint would be 90. Your right endpoint of your shading would be 120. Your mean would be 100 and your standard deviation would be 15. But now, what if instead it said, what's the probability somebody's got an IQ above 120? Well, here's 120. Above, remember, we're going to shade to the right. This is one of those times where you might have to fool the calculator. See, it's the left endpoint of the shading, not the left number on the picture. Okay, so the left endpoint of my, here's my shading. That's the left side of my shading. That number is 120. My problem is I don't have a right endpoint. So if I don't have a right endpoint, I've got to fool the calculator. So that's where in the video I told you, I just write a ridiculously big number with a bunch of nines. Nobody's going to have an IQ above 9,999. Okay. And then my mean is 100 and my standard deviation is 15. So if you're missing the left endpoint, you put a negative and a bunch of nines. Okay, so make sure you go back and review on the videos what happens when you're missing one of those endpoints. All right, now, if somebody had said 25 people are selected, what's the probability that their average IQ is above 120? Well, if I'm grabbing 25 people, that would be central limit. So the first thing I would do is take my old standard deviation of 15, and I would divide by the square root of I picked 25 people. So you're going to end up getting 5 on your well, 3 on your calculator when you do that. So the only difference would be my left endpoint would be 120. I'm still missing my right endpoint, so I make up a huge number. My mean's 100, but this time my standard deviation would be 3, not 15. So central limit just means you're getting a group, more than one. So the only thing you do different is you fix the standard deviation before you start, then it's the same thing. You go to second VAERS, you pick normal CDF, you put down the left endpoint on your shading, the right endpoint on your shading, your mean and your standard deviation, and then you pick your p-value. Okay? So that's one kind of question on the test, find the probability. Any questions? Okay, now another thing out of chapter 6. It'll ask you to find a value. Now, you still draw the picture. And by the picture, I mean the normal curve. You're still going to shade. But this time, you always shade left. So you shade left of the value you're looking for. Terrible grammar. All right. Then you use the calculator again. Where do you go? You go back to second VAERS, just like you did last time. But this time, you're going to choose inverse norm. And this time, it doesn't want 4 things, it wants 3 things. It wants the area to the left, it wants the mean, and it wants that standard deviation. Okay? So for instance, what if it said this? What IQ score separates the top 6% from the rest? And it tells you that IQ scores are normally distributed for the mean of 100 and a standard deviation of 15. I'm just going to put SD. Now, the word normally distributed is in there, but it didn't ask me to find a probability. So it doesn't ask me to find a probability. It doesn't say how many people must you sample. It doesn't ask me to construct a confidence interval. It doesn't say anything about linear regression or linear correlation. It doesn't say test the claim. So it's got to be find a value. So find a value, see what IQ score. So I know I've got to draw the picture. Now, it says normally distributed, so I've got a normal curve. You know, in the middle of a normal curve, you always put the mean. Now it says what IQ score separates the top 10% from the rest. So you have to use a little common sense. Where's the top 10% going to be? Way on the right or way on the left? Well, it'd be way on the right. That area right there is 6%. So I'm looking for this IQ score right there where that bar is. But notice what it says. I've got a shade to the left of what I'm looking for. I'm looking for that number, so I've got a shade to the left. So I'm going to have to use common sense. I need the area to the left. Well, I know if this is to the right, if it's 6% to the right, all the rest has to be to the left. So 100% minus 6% tells me that that's got to be 94%. And as a decimal, that's 0.94. So when I go to second VAERS and I go to inverse norm, my area to the left is going to be 0.94, not 0.06. I need the area to the left. And then my mean is 100 and my standard deviation is 15. Okay? So when you're looking for a probability, sometimes you shade left, sometimes you shade right, sometimes you shade between. But when you're trying to find a value, you have to shade left. Okay? And that kind of takes care of chapter 6. Okay? Now let's talk about chapter 7. The first thing it might ask you is to construct a confidence interval estimate. Now, there's 2 possibilities. It might ask you to do it for proportion. Now, percent or percentage is proportion with 1 extra step. Okay? If it tells you to construct a confidence interval estimate of the proportion or construct a confidence interval estimate of the percentage, the first thing you put on your paper is you put P between 2 blanks. Your formula sheet does not tell you, that's not on your formula sheet. So you may need to write that on the back. Now, another thing it might say, it might tell you to do a confidence interval estimate for the mean. If it says mean, you put mu between 2 blanks. You do not put your answer as 2 numbers inside of a parenthesis the way your calculator does. If you write your answer that way, I'm going to take points off. You can't be that lazy. Okay? So if it's confidence interval proportion, I want a P between two blanks, and the calculator gives you the numbers to put in those blanks. If it says to write a confidence interval estimate of the mean, you put mu between two blanks, and the calculator gives you the numbers to put in the blanks. Now, where do you go now? For both of these, you go to stat, and then you go over to where it says tests. Okay, so you don't go to second VAERS, you go to stat and you go over to test. Now, if it's a confidence interval for proportion, you're looking for one prop z int. Int for interval. Now, there is a one prop z test. That's not what you pick. There's a two prop z int. That's not what you pick. So you've got to be real careful that you're picking one prop z int. And when you do that, it's going to ask you for your x value, it's going to ask you for your n, and it's going to ask you for your C level. Your C level is a confidence level. Your C level must be a decimal number. So if it says 99% confidence, you put 0.99. If it says 92% confidence, you put 0.92. X and N cannot be decimals. They have to be whole numbers. If you put a decimal, it'll give you an error message. So if you have a decimal for some reason, you have to round it off. Okay. Remember, N is always your total, so you shouldn't get N and X confused because N's the bigger number, X is the smaller number. And then you hit calculate. And when you hit calculate, it's going to give you two numbers in a parenthesis. The left number goes in the left blank, the right number goes in the right blank. That's proportion. If it wants percent, then you multiply both of those numbers by 100 and turn them into percents. So if it says proportion, you leave them a decimal. If it says percent, you change those decimals to percents. Okay. Now, if it says confidence interval for mean, you either go to T interval, which is usually what you do, or occasionally you'll do Z interval. Now, again, be careful. Don't pick T test. They tried to do it and make it easier for you by, if it's a confidence interval, you have to pick an interval. Okay. How do you know whether to do T or Z? You look at where your standard deviation came from. If your standard deviation is from a sample, which is usually what's happening, do the T one. If your standard deviation came from a population, then you pick Z interval, which is pretty rare. So in other words, this means that they gave you an S value. This means they gave you a sigma value. Okay. Now, occasionally, if they give you a list of data, you're going to have to go figure out your mean and your standard deviation. Okay. And again, C level is going to have to be a decimal number. N's got to be a whole number. All right. So make sure you go back and rewatch that video on how to find the mean and standard deviation of a list of numbers if you don't remember how to do that. Okay. So construct a confidence interval. If it's proportion, put P between two blanks. If it's mean, put mu between two blanks. Again, when you do this in the calculator, it's going to give you some numbers in a parenthesis, like 55.143, and then maybe 61.220. Then that 55.143 would go there, and that 61.220. So you wouldn't give me this, you'd give me this. Okay? So confidence intervals. The other thing it might ask you to do out of chapter 7, so this is kind of the fourth kind of question, is it might ask you to find a sample size. Now, the thing to remember about sample size is you have to round up, not off. Because the number from the formula gives you the minimum. It gives you not the only sample size, the minimum sample size. All right. Now, what you do when it tells you find a sample size, or remember, it might say how many, you go to the formula sheet. Because the formulas for sample size are on the formula sheet. All right, so it may have something like this. You know, I mean, you got all kind of things, you know, so the formulas are on the sheet. Okay, or it may be something like, so you got to go find the formula on the sheet. So if out of this formula, it comes out to be 362.158. I know that that number is smaller than 5. So I know this number rounds off to 362, but I'm not rounding off, I'm rounding up. So the smallest I could sample is 363. Now, if I ask you, is 400 okay? The answer would be yes. Why? That's the minimum. So I can pick that number or anything bigger. If I said, is 360 okay? The answer would be no. You can't go below that number. So you can sample this number or more, but you can't sample less. Okay, so make sure you remember that you got to round up on your sample size. Okay, and those formulas are on the sheet. And there's two formulas. If you can't, if this one's proportion or percent, if you can't find p hat or q hat, then there's another formula that's got a 0.25 right there. Remember, E is your error. Your z-scores are on your formula sheet on the bottom right. You don't have to figure those out. They're just written on the bottom of the right-hand side of that formula sheet. Like for a 95% confidence interval, this z-score is going to be like 1.96. And you'd square that times 0.25 divided by 1 point whatever, you know. So the formulas are on the sheet. You don't have to memorize those. The z-scores are on the sheet. Okay. Now, so that pretty much takes care of chapter 6 and chapter 7. Chapter 8 is hypothesis testing. All right, and you do them about proportions. Again, instead of proportion, it might say percentage. And you do them about mean. Now, this is the one where you have two hypotheses. Now, if I don't see all of this stuff written down, I'm not going to take your answer. So the first thing I want you to do is read the problem. And then I want you to find this phrase. Test the claim that. And I want you to underline on your test what follows. That phrase. Because that's what you're going to change to a mathematical sentence. Okay? Test the claim that the average weight of your male is 1.6 ounces. or is more than 1.6 ounces, okay? So if it's a proportion in your statement, you've got to use a P. If it's a claim about a mean, you've got to use a mu. Okay? And then you put the word claim next to it. So if it said something like, test the claim that the mean weight of your male is more than 4.8 ounces. And that's what you've underlined. Then it says mean, so you'd use mu, more than 4.8, and you'd write the word claim next to it. Then you have to have another sentence that encompasses all the other possibilities. So if the mean's not more than 4.8, it would have to be less than or equal to 4.8. So you have two hypotheses on every problem. One's called the alternative and one is called the null. And the way you know, remember, is the null always has an equals in it. So this is the one that has the equals, so that must be my null hypothesis. This one doesn't have, so that must be my alternative hypothesis. And the reason you need to know that is this alternative hypothesis, that's the one that tells you what test to use. You're either going to run a left tail test, a right tail test, or a two tail test. So I look at that alternative, it's got greater than. It's pointing to the right, so I'm going to run a right tails test. And that means when I go to the calculator, I'm going to pick that symbol. So the alternative tells you what to pick on your calculator, because you pick the wrong one, you're going to get the wrong probability. Alpha is your significance level. It'll just tell you in the problem, use a significance level of like 0.01. Because what you're going to do is you're going to find a p-value and you're going to compare that to your alpha. For that p-value, you get that from the calculator. Now, for proportion hypothesis testing, again, where do you go? You go back to stat and you go back over to tests. If it's probability, if it's proportion, you're going to pick one prop Z test. Now remember, when you were doing confidence intervals, you picked one prop Z int. So make sure that if it's proportion interval, you pick Z int. If it's proportion testing, you pick Z test, okay? If it's mu, then again, you go to stat and over to test, you either pick T test or you pick Z test. And it's the same way when you're doing intervals. If your standard deviation comes from a sample, you use T test. If your standard deviation comes from a population, you pick Z test. Now, if your p-value is less than or equal to alpha on your paper, you're going to write down reject the null. If your p-value is bigger than your alpha, you're going to write down failed to reject the null. And then you're going to use that flow chart on page, I think it's like 366. I'm going to give you a copy of the flow chart and you're going to write down your sentence answer. But if I don't have all of this, you have to tell me what your two hypotheses are. You have to tell me what test you're running. You got to tell me what your significance level is. You've got to tell me, did you do one prop Z test and everything that you typed in? You got to tell me that you used T test and everything that you typed in. I've got to see exactly where you went on the calculator. You've got to write down what you typed in. You've got to tell me what your p-value was and what your alpha was. So if you got something like 0.003614.8, and maybe your alpha was 0.05. Well, see, that number is smaller than that number. So then you'd write down reject the null. And then you'd write down your sentence answer. If I don't see all of that, I won't take your final answer. Okay? So make sure that you go back and rewatch those videos on hypothesis testing, and I tell you exactly what I want you to write on your paper, and make sure you write it all down there, because that's what gets you partial credit. And partial credit is your friend, because these problems will count like 10 or 11, 12 points each. So if you don't have written down every little nitpicking step, I'm going to count off a point for everything that's missing. But I'm also going to give you a point for everything that's there and right. So if you do what I tell you on that video, it turns out really well. Okay? So hypothesis testing. And like I said, I will give you a copy of this flow chart. You don't have to write it on the back of your formula sheet. I will give you a copy of that that flow chart out of your book. Okay? And then the last thing that's on your test is chapter 10, and that is linear correlation, which is really a kind of hypothesis testing. So what'll happen is it'll give you two things. It'll give you a chart with something like head size, IQ. You know, I mean, and it'll give you, you know. So what you're going to do is you're going to put this top row, you're going to call that your X value, and you're going to put it in like list 1. This bottom row is going to be your Y value. You're going to put it in list 2. And again, if you haven't watched the videos, watch those to see. Then you're going to run a test. And where you go is you're going to use the calculator. All right. And for that calculator, again, you're going to go to Stat, and you're going to go back over to Tests. And this time you're looking for linear regression t-test. It's way down there. So I think your calculator has like LINREG t-test. All right. And when you do that, it's going to say X list. Well, you got to tell it where'd you put your X's. And so make sure you also tell me, well, that was the head size. Because if you don't, you're going to get lost. Why? Maybe that was the IQs. So your X list, you used L1, your Y list, I put those in L2. You always choose not equal to when you're doing linear regression. Now, when you're doing chapter 8, sometimes you pick less than, sometimes you pick greater than, and sometimes you pick not equal to. You pick whatever symbols in your alternative hypothesis when you're in hypothesis testing. But with linear regression and linear correlation, you're always going to choose not equal to. And again, you're going to have a probability from the calculator that you're going to compare to your significance level. All right. And if P is less than or equal to alpha, you're going to write that you have significant blank linear correlation. All right. If this p-value is bigger than alpha, you're going to write you do not have significant linear correlation. There's no blank. If you don't have significant linear correlation, the game is over and you're finished. You write that down and you just quit. If you do have significant linear correlation, in this blank is either the word positive or the word negative. And the way you know that is you look at your R value on your calculator. And the video will explain what the R value is. If the R value is a positive number, you write positive in that blank. If the R value is a negative number, you write negative in that blank. And then at the top of your screen on your calculator, it's got this. It's got y equals ax plus b, okay? That is your linear regression equation, and the calculator will tell you what value to put in for A and what value to put in for B, and that will give you a predicted value if the problem asks you that. The video explains that to you. You don't have an equation if you don't have correlation. And the video reminds you that positive correlation means when one goes up, the other goes up. So if head size and IQ are positively correlated, that means the bigger the head, the higher the IQ. When one goes up, the other goes up. Negative correlation means when one goes up, the other goes down. So maybe as the head gets bigger, you get dumber, okay? So your IQ be dropping, okay? So if you have significant correlation, that means if I know something about one, I can predict with some accuracy something about the other one. That's why we do linear correlation. But the video explains all that to you. Okay? And those are the only question types that I can ask you on your final exam. So it's either going to ask you to find a probability, or it's going to ask you to find a particular value, or it's going to ask you to construct a confidence interval estimate, or it's going to ask you to find a sample size, or it's going to ask you to test a claim, or it's going to ask you, do you have significant linear correlation? Those are the only 6 kinds of problems I'm going to ask you on your test. Okay? Now, so that's kind of a quick, kind of an overview of what's going to be on your test, those 6 question types. So you make sure when you read the word problem, the first thing you decide, you look on the back of that formula sheet that you've written out, those 6 questions, which kind of question is it? Then you go to that little part of the outline. If it's confidence interval, it's either proportion or it is mean. Where do I go for proportion? Where do I go for mean? What do I type in? Now, in this week on Canvas, you're supposed to finish up chapter 10, and those problems are due Sunday night, but you need to really finish them way before Sunday night, because there's also a review. You need to spend most of the week, especially the weekend, going over those review problems. So you saw in the midterm, when the questions are all mixed up, when you don't have your notes, it's a lot harder than when you're doing the problems with your notes. You know you're in chapter 7. You got unlimited attempts on web work. All right. And some of us struggled on that midterm and didn't do very well. So I need you to pass this final. Okay. So I need you to get to that review. So if you're getting confused, you can email me and we've got time to Zoom. Okay. Let me stop this.